Hey, we have an interesting integral on the board. We have the integral of 1 over 1 plus tan x dx. And I wanted to go over this one because it just has an interesting method of solving. There's an interesting trick that we can use to clean this up. So to get started, I'm going to write the tangent as sine over cosine. So we'll write the integral of 1 over 1 plus sine x over cos x dx, and I'll leave some space because what I want to do is I want to multiply the numerator and denominator by cosine of x. So we'll multiply this in here, and let's rewrite this. So we'll have a cosine x in the numerator, cosine x, this one will cancel, and so in the denominator we just have cosine x plus sine of x, and this will be dx. What we really want is we would like there to be maybe a sine x here, and then this becomes 1. Or even if there was a negative sine x here, you'll notice that the derivative of the denominator would be the numerator, and then we could do a nice u substitution, but that's not the case either. But what we can do is we can try to somehow make that happen. So let's try to manipulate it to get it to that form where we can use that. So to start with, what I can do, I'll multiply this by 2, and then we can divide by 2, so that we're just multiplying by 1. So I mentioned I wanted to add a sine x before, but I also wanted to subtract the sine x. So we'll do both, and notice that that's 0 and doesn't change the expression at all. And we'll write in our dx. So now by multiplying by 1 and adding a 0, we haven't done anything to change the integral, but now we just want to arrange it into that form that we mentioned before. So let's rewrite this as a half cos x plus sine x. We're splitting this cos x here into cos x plus cos x. And then we'll write another one, and then we'll have our minus sine x here, all over cosine x plus sine x. Then for our next step, we'll just split this into two integrals. We'll split it right here. So we'll have half cos x plus sine x dx. And then I'm going to distribute this half. And then in our second integral, we'll have cos x minus sine x all over cos x plus sine x dx. Now here, you'll notice this is just 1. So that's going to be real easy. The integral of 1 is x. So when we integrate here, we'll have our half, and then we'll have an x. And then for our second integral, we're going to do a u sub. So we're going to call this piece u. And then, like I mentioned before, if we just take the derivative of this, we get minus sine x. I just got the order wrong, plus cos x, but that's what we have up here. So we can rewrite this integral. We can rewrite this second part as half du over u. But then this integral du over u, this is just actually the ln of u. So we're going to have half x plus half ln absolute value of u plus c. But let's just substitute back in our value of u for our final answer, and we're going to have half x plus 1/2 ln absolute value sine x. I don't know why I just changed the order, but I did, plus c. And that's the answer. Now what I'm going to do, I actually recorded this video before and it was getting too long and complicated because I included a whole bunch of other stuff. So what I did is I split this into 3 separate videos. So in the next video, I'll do this again, but just a different way.